My name is Fatih. I'm a senior Android developer at the MB Bank for Mobile Bank project. Today, we are going to be talking about how to use live data with Flow in MVVM architecture. So today's agenda is first we're going to be talking a bit about how to use live data in MVVM, but I'm sure most of you are familiar with this one, so I'm going to keep it short. And then we're going to start using Flow in repository level, and in the vModel level, we're going to be using live data. Then we're going to replace live data with Flow, and we're going to see how we can use Stateflow. At the end, we're going to see how we can test all the scenarios that we have written. Yeah, let's start. So, what are the advantages of using live data? So, because live data is a lifecycle aware component, right? So, because it's a lifecycle aware component, there is no memory leak. I mean, you just give your lifecycle. So, out of that lifecycle, there's the live data is not active. So, there is no memory leak. And live data has a cache value, the last value. Live data keeps that one. So these are some of the advantages of using live data, but there are some disadvantages of using live data. So let's see what are they. Uh, Live data doesn't support back pressure, and live data, if you're trying to make some data transformation with live data, it's kind of limited. So you have transformations, and whenever you try to map something, it's you have map or switch map. So they're going to be handled on the UI thread. So yeah, it's kind of limited transformation with live data. But you can use live data builder here, but still you're gonna have two functions like map and switch map, not more than that. So the third one is it's only lifecycle aware. I mean, it's good in your activities or your fragments, but it's not good if you use live data in a repository layer. So it's kind of like a bad practice to use live data in repository layer. So there should be another alternative for that one, but we are going to talk on that one later on. So that's some of the disadvantages of using live data. Today we are going to build a weather forecast app. It's going to be with a fake data, and we're going to see how we can make a one-shot request and how we can get a uh, data stream of the weather forecast. So our architecture will look like this. In vModel, we are going to use live data, but in repository, if you have used coroutines before, or if you're using coroutines, you might be familiar with suspend functions. So in repository, we are going to use suspend functions. And let's get started with the repository actually. So in our repository, let's say we have this beautiful method called fetch weather forecast, which is a suspend function. It just I just faked the API call rather than making an actual API. I just faked it, and it just returns a random success value as an integer. It's very simple function. So let's say you have a cache or a local database. So what you would prefer maybe is this one. If you have it in the cache or local DB, you just get it from cache. But if you don't have it, get it from the API, like make API call. So in order to do that, you can only return one single value from this function, not more than that. Like you cannot just return both the cache and the API call at the same time. So we can fix that one later, but just keep in mind that you just return one value here. So this is the repository. And what about vModel? Let's go and check the vModel. So in our vModel, we have one live data, which keeps the weather forecast. And whenever the vModel is created, we just call fetch weather forecast inside the vModel. And whenever this is called, we set the live data's value as loading because we have a suspend function and it only returns one value, which is the API result in repository. we have to set the data, drive data as loading before we get the API call, API result, and then we make the call. Since it's a suspend function, it needs to be called from a coroutine scope. The best choice is here to use vmodel scope, which is like your operation is going to be canceled when the vmodel is destroyed. So it's better to use vmodel scope here. And whenever you get the result, you just set the result to live data's value, like update the live data with its value. So the thing is, we have to set the loading state every time to live data, which is a bit tricky or maybe boilerplate. So we will fix that one later, but just keep in mind that it's something that needs to be fixed. Yeah. How about like in order to fix this, like every time you need to set this loading state and you get the API result, etc. So in order to fix this, you you have to be able to return multiple values from that suspend function from the repository, right? If you would have been returning loading and the API result at the same time from a single function, that issue was already fixed. So let's see how we can fix that issue. But before that, let's give an example from the Twitter. So everybody is using Twitter, right? Whenever you open the Twitter app, you see some tweets from the local database, and there's some API call at the background, and you see some new tweets from the API. So it's like this: you open the Twitter app, and you get the tweets from the cache or local database, and you update the UI with the local one, and then at the same time you are fetching new tweets from the server, and then you update the UI with the new tweets from the server. So in order to achieve this kind of functionality, you might need something similar to this one in suspend function. You need to first return from the cache inside the suspend function, and you need to return from the API result. But since you can only return a single value from a function, you cannot do that, right? So this is where flow comes in, actually. So let's see what flow is, first of all. Flow is a called reactive stream which can return asynchronously computed values. So what is called reactive stream means? It means that when you have some code inside the flow, and whenever the flow collection, I mean in terms of flow it's collection, but like in live data you call it observe, but in flow it's collection. Whenever the collection starts, the code inside the flow is going to be executed. But if the collection does not happen, so it's like a call, it's there. Nothing happens. Even if you call the function that wraps the flow, nothing happens. We will see it. So what are the pros of some of the pros of flow? Since it's inside the coroutines, like you're using with coroutines, you're making use of structured concurrency. And if you want to make some data transformation, there are a lot of operators that Flow provides. And with that operators, actually, you can call, like you can do any asynchronous work, which is very cool. And in terms of testing, it's very easy to test. You can get the all flow data and put it inside a list with toList function and just test the list with list operators. So it's pretty cool. And now we're going to change our repository layer with Flow. So our repository layer, we're changing from suspend to Flow. Now we're going to use Flow in the repository. And in the Vim model, we will still use live data. Let's see how we change the repository layer. So now we have this function, the same function. We are removing suspend function because now this flow is not suspend because it's a call stream. We remove suspend, it's not a suspend function anymore. And we're using a flow builder, which obviously returns a flow. And we, instead of returning something in flow, we are emitting. So whenever you emit something, you send the data to collector side. So first we are emitting loading, and we are faking the API call for 1 second, and then we are just returning a random success value. So let's see how we can use this flow in the Vim model. So in the Vim model, now as you remember, now it's not a suspend function, right? Before it was a suspend function and you needed to call it from a cartoon scope. Since this is not a suspend function anymore, you can directly call the repository function like this. So it returns a flow, and we need to convert that flow to live data in vModel. Luckily, we have a live data extension, and we just convert flow to live data, and then we just expose that live data to UI. So in the UI, there's nothing fancy here. It's just a live data. You just observe as usual how you observe live data. So that's it. You just observe the live data in the UI. And this was actually one-shot request, which means you just make a request, you get response from the API, and it's done. Nothing, you're not expecting any response or any other response in the future. But what about data stream? Like you just make a request and you get some data, but in the future you might get some data, like the connection is still open. Think it like a messaging app, like anytime the message can come. So what about the data stream? So let's go to the repository again and add another function called fetch weather forecast real time. So what it does is actually I just try to mimic the real time update from the API. So in order to do that, I put an infinite while loop. So every 1 second, it just returns a random success value. That's it. And the cool thing here is because flow is going to be collected from a scope inside the UI. So this while loop is alive whenever that scope is alive. Like whenever that scope is canceled, this while is also going to be canceled. So it's safe to do it like this, and there is no leak actually. And in the repository, we just do this. And what about the vModel? So let's go to vModel. Because we are still returning flow. It's the same. Like we're just calling the fetch weather forecast real time method, and we're converting the live data, and we're observing that live data. Yeah, is that all actually? But no, it's not all with Flow. Let's go and see what else we have. So with Flow, I think the powerful side of the Flow is the operators. So we have two kind of operators. The first one is called intermediate flow operators, which is which is used to make some data transformation in between the producer and the collector side. So you have a bunch of operators here. So let's give an example for a couple of them. So for instance, map operator. We have map operator. Let's say you're getting some data as Celsius from the backend and you want to convert it to Fahrenheit. So map operator is best place to do it. And you can just convert from anything to anything inside the map operator. But the cool thing here is in every flow operator, you can call suspend functions, which makes asynchronous. Like you can do some asynchronous work inside the flow operator. So as you can see, I just put a delay function here, which is a suspend. So yeah, you can do anything inside here and it will not block the UI unless you use default dispatcher's main in the coroutine context. So we have this as live data extension here. So the thing is, whatever context you give here or in the collector side, the operators are going to use that context, and the operations inside that operators is going to be executed with this context. So in here, it's going to be executed with dispatcher default and the vModel. So I added vModel scope in order to auto cancel all the operators whenever vModel is destroyed. So we have another operator called onStart. So as you remember, we were just setting loading state to live data whenever a request happens. Instead of doing this, we can actually use onStart operator to emit loading state for each collection. So this is the best place maybe you can use before starting to collection actually. And we have filter operator. This is actually the same with the list filter operator, but you can think it's an asynchronous filter operator from the list. Like you can do any asynchronous work inside this filter operator. For instance, we're just filtering the numbers, like the data which is less than 10. And if it is greater than 10, it's just swallowing other things. Like we're not sending anything to UI. But if it is just loading or error, we're also returning that one. So we also have on each operator. This is actually used for each data. Let's say you want to save data to your database. That you can use to do anything for each of the data with on each operator. And we have something called flow on. This is used to change the coroutine context of the operators. So for instance, if you want to change the coroutine context that these operators are going to be executed, you can use flow on. And we have catch operator. So whatever error that is thrown from the upstream flow will be catch here. So the important thing here is all the flow operators like for instance for here the catch operator is going to catch all the errors from the upstream but not the downstream. So upstream here is on start, filter, map, on each, and flow on. But if you add any operator after catch, let's say you added a map operator after this catch, and this catch operator will not catch the error from the downstream map operator. So you have to be careful about using operators in order. And we have seen how to use flow in repository layer. Now, why not only flow? Let's just remove the live data and use only flow. But before doing that, let's just remember a couple of things. Flow is a code stream, as I explained. It's the code inside the flow is only going to be executed whenever the collection actually starts, and it's actually not equal to live data because it doesn't have a cache value. It does not have any latest value kept inside. So the problem with Flow is whenever the configuration changes, you have to, like, let's say you have an API call inside Flow, and whenever the configuration changes, you have to make the API call again. So this is why we have state flow actually. So the state flow has been introduced quite new. I think it's been like at most 1 month. So we can safely replace live data with state flow, but not actually flow because it doesn't have the latest value inside. So first, let's start with how we can use flow, and then we will see how we can use state flow. So since the repository layer is the same, because we were already using flow, let's change the view model layer. So inside the view model, actually, and we are going to just have this flow, but sorry about the naming, by the way. I couldn't find any name. It's pretty long, I know. But here, as you can see, we don't have no as live data. Since we're not going to return live data, but we're going to return flow, we don't have as live data extension. We just remove that one, and instead of returning live data, we just return expose flow to UI. And in the UI, instead of observing live data, now we have the collection of flow, which is actually called, like here, terminal operator. As I said before, we have two kind of operators with flow. The first of them was intermediate flow operators, and now we have terminal operators. So intermediate operators were used to make some data transformation, whereas terminal operators are used to start the collection of the data with flow. So we are using this collect operator to start the collection of the data. Since this is a suspend function, we need to call it from a coroutine scope, which here I call with lifecycle scope, but you can also use launch here instead of launch when started. So the difference between like observing live data and collecting flow is because collect is suspend, you need to call it from a suspend, you need to call it from a coroutine scope. So that's the only difference actually. And now this is flow. But if you rotate the screen, or if the configuration is changed As I said, with Flow, you will make the API calls again because it doesn't have the latest value. So now let's see how we can use Stateflow. So with Stateflow, you can safely replace live data with it. So it's pretty similar with live data. For instance, we have something called mutable Stateflow, which is very similar to mutable live data. You have the initial value, you can give the initial value to that one, and you have something called Stateflow, which is immutable. The value itself is not changeable. So you expose this one to UI. Let's say you just make an API call and change its value, and you're observing or you're collecting that flow inside the UI like this. Now, because we change its value to 15, it's going to print 15 here. But let's say afterwards you want to change its value again, right? So easily you can just change like live data, where forecast that value. This is coming from stateflow, so you can just change its value and all the collectors will be notified. So in this case, this is going to print 22 in this print inside the collect operator. So this is how you can use Stateflow. The other thing that I want to mention here is we have something called state in operator, but it's not yet there. It's not ready yet, so it's still open. So what it does is it actually, if you have a flow, as we had here, like in vModel, if you have a flow operators, you are collecting the flow, you can easily convert flow to state flow with state in operator, rather than just creating mutable state flow in the vModel, etc. You can just convert flow to state flow with state in operator, but it's still open, so it's not yet there. Whenever it comes, you can check it out. So is that all? Actually, not. I think it's the most important part is testing. So we're going to see how we can test all these things, all the scenarios that we have mentioned. So first of all, let's start with live data. So live data has some problems with if you're using coroutines. So you need to be careful about the race condition, because if you're using live data with coroutines and if you're not injecting the correct dispatcher, if you're not using this the correct dispatcher, so you will see some red in your CI, and you will see that, okay, what is the exact reason that is like, why is it failing? You will not understand easily. So you need to be careful if you're testing live data with coroutines. And then if you're using transformations, so you're actually getting new live data, and you should not forget to observe that live data again, etc. So there are a couple of things that you need to remember when you're testing live data with coroutines. But with Flow, because it's sequential, and because it has a back pressure, it means that you will get every value that Flow emits, right? So it means that there is no race condition. You will get every value, every emitted value from the flow. And the coolest part is you can actually test like a list with toList function. So we can get all the flow, all the data inside the flow, and put it inside a list with toList function, and use the list operators to test your flow. That's very cool. And yeah, let's see how we can test first suspend functions like live data with coroutines, and then we're going to see how we can test flow. So first, let's start with this function. This was a suspend function which was just laying for 1 second, and it was returning a random success value. If we were to test this function, this function should return success value. So how we test this function is we first of all use run blocking here. Because it's a suspend function, it needs to be called from a coroutine scope, which here we use run blocking for tests. And then we call that suspend function, and then we assert if the result is success or not. And then this test is passes successfully, of course. This is a very simple test case. But in the Vim model, the things are getting more complicated actually. So we had this function in the Vim model, which was first setting the live data's value to loading, and then starting a new coroutine with launch, Vim model scope launch, and then calling the suspend function from the repository and setting its value to live data. So if you try to test this, as this should first post loading, and then I should get success after that. So how we can implement this is like this. So first, we are going to use run blocking again because we're going to call suspend function from repository. We're going to use run blocking here, and first we are going to assert if the first value of live data is loading, and then we will wait for 1 second since we are delaying 1 second in the repository. I know this is not a good approach, but we will remove this delay too. But for now, let's just be there for testing purposes, but we will remove this delay soon. We're just delaying for 1 second since the repository is delaying for 1 second. And then we're asserting if the result is success, the live data value is success or not. So if you run this, this test won't pass because it will give you this error. It says that you're actually trying to get the main looper from the looper, which is inside the Android operating system. And the Android operating system is not open for unit test. I mean, you cannot reach the source code from the unit test. So it will throw a runtime exception. So in order to fix that, we have a rule called instant task executor rule, which has two things. Like it will first mock the get main looper function, and if the and then it will actually change all the architectural components from a background thread to a main thread. So instead of like having this all ruled by yourself, there is already rule if you want to change all the architectural components from background thread to main thread. So if you run it now, you will get another exception. It says illegal state. Now you try to access the main dispatcher. Now it's about coroutines. You try to access the main dispatcher, and it's failed to initialize. It's because dispatcher's main is inside Android main looper, and then like calling Android main looper, and it's also inside Android operating system. So in order to fix this, we have another dispatcher called test coroutine dispatcher. Instead of using dispatcher main, if you use test coroutine dispatcher in your test, all the tests should be fine. Let's see how we can implement this. So for this one, we have one rule, which just creates a test coroutine dispatcher, and then at the start of the test, it sets the main dispatcher to test dispatcher. So whatever what this dispatcher set main does is it just overrides the main dispatcher to test dispatcher. But the thing is, it just overrides the main dispatcher, not the IO or not the IO or default dispatcher. That's the downside of this one, this function. And whenever it's finished, it just resets the main dispatcher. So let's see how we use in the test. So you add this rule here, and now instead of using run blocking, we have run blocking test coming from test dispatcher. So why are we using this? It's because it has two things. Like we're going to inject this test dispatcher. That's the first reason. And the second reason is run blocking test has a virtual time, virtual clock. Whatever delay inside the test function, it will just skip that delay logically, and then you are not going to actually wait for that one. Like for instance, if we are delaying for 1 second here, it will not just wait for 1 second. It will just shift the time by 1 second, and then you will not actually wait in the test, which is pretty cool. So if you try to test like this, it's going to pass. But there is actually one more issue inside our view model, which is this one. So inside the fetch weather forecast method, we were launching the coroutine with main dispatcher. So if you say vmodel scope.launch, by default, it will use dispatcher's main. So which is not a good practice because if you're making a network request, you should use dispatcher IO for this one. Otherwise, you're going to block the UI with dispatcher's main. So if we change it with dispatcher IO like this, then our test is not going to pass again. Why? It's because of this one. Let's visualize it. So you were using test cartoon dispatcher, test thread on the test, but whenever you call the fetch better forecast from the Vim model, you actually launch a new cartoon with dispatcher IO. So it will be executed on a different thread. And inside your test, your test doesn't know that a new cartoon has started and it needs to wait for that one. So it just makes the assertion right away and your assertion fails. So in order to fix this one, you have to inject your dispatcher like this. You can inject your dispatcher and use that dispatcher here. And in your test, while you're creating your view model, you give the test dispatcher we already created in the test, so that it will be all the cartoons are going to be executed on the same thread. And while you're using this, since you're launching a new cartoon with run blocking test with test dispatcher here, it will all be going to execute it on the same thread. So if you use this test is going to pass. Yeah, now we have successfully created a test case for LiveData and Kotlin, but there is one problem here. As I said, we are using delay for 1 second. If we use delay 500 here, like if we delay for half of second, then the test is not going to pass. So we need to kind of remove this delay in the test and in the API also. So what we can do is we have something called pause dispatcher and resume dispatcher inside the test dispatcher. So what it does actually is it pauses dispatcher for new coroutines. So if you pause the dispatcher and try to launch a new coroutine inside that dispatcher, it will be paused. It will be just paused there, and then whenever you say resume dispatcher, then the new coroutine is going to be executed. So let's see how we can use that one. So here we are first pausing the dispatcher, not to launch a new coroutine inside the vModel. And then we have our vModel creation here. Whenever you create your vModel, it will go to vModel, it will call this fetch weather forecast. And inside this fetch weather forecast, we are setting loading state to live data. But now the coroutines dispatcher will not execute this one because we already paused the dispatcher. This is a new coroutine launching and it will not execute this one. It will come back to test method again. It will execute the assertion. And then whenever you say resume dispatcher, it will go to the fetch better forecast method and this coroutine launch is going to be executed. You call your suspend function from repository, you set its value to live data, and then now you can safely assert live data's value with success, and this is going to pass. Yeah, so our test is passing without delay. Now we have seen how we can test coroutines with live data, and let's see how we can test flow. Now we have this function in our repository, which first emits loading, wait for 1 second, and then emits a random success value. This is not a suspend function. I want to repeat it again. So in our test, we need, just to call that function, we don't need coroutine scope. But since we are going to collect the result from the flow, we need run blocking here. And how you collect is like this. So how you collect in UI, you just collect in the test like this too. So you collect the data from the function, from the flow, sorry. And since we don't have index here, like we need to check if the first one is loading and the second one is success value. So since we don't have index in collect, let us use collect index, which has both index and value inside. So if you use this one, you can safely check if the first one is a loading result and the second one is a success result. So it's pretty cool, but we can do it more. We can convert all the flow to list, put all the data inside a list, and then we can actually check if the first one is loading and the second one is success. So instead of using like the indexes here, hard coding indexes here, you can also use like this. You just convert to list again, and you can use the list operators. Every list operator can be used because it's a list. You just convert flow to list and use the list operators to test the flow. So the first one is loading, and you check the second, the last one in our case is success. So we have seen how we can test the flow too. So I think it's easier to test flow than testing the live data with coroutines because it's sequential and it has a back pressure. Because in coroutines with live data, you should remember a lot of things with coroutines and live data. So, but in flow, it's not like that. You just test it because it's sequential. As a TLDR, um, flow and live data are very similar, but not the same. But you can safely replace your live data with state flow. If you're making one-shot request, if you're using coroutines, you might prefer using suspend functions or flow in your repository. And if you're already using live data, you can use vmodel. You can use live data inside your vmodel. But if you're making a data, getting a data stream from your server, you might prefer using flow instead of suspend functions in your repository. Uh, Last but not least, testing live data, as I said, it's a bit hard with coroutines and you need to remember a lot of things. But testing flow is pretty much simple, and you just test it like a list. Yeah, that's it. That's very easy. Yeah. And thank you for listening me. If you have any questions, I would like to answer them too. And stay safe.